Hello everyone, welcome back. Now today is going to be a very similar video to last video, though this time we're not inverting a 3x3 matrix. This time we're actually going to attempt to prove that this was the correct inversion of this 3x3 matrix. And it's going to be the same process as the process that we had to undergo for the 2x2 matrix in order to, because if it was a proper inversion for that matter, we should result, the multiplication here should result in a identity matrix. And if you still don't know what that is, go back to my video on the identity matrix. So this is what it should look like. This is what the product should result in this matrix, this 3x3 matrix. So why don't we get started? So we want to multiply this matrix by this matrix. So let's write that out. Okay, times, let's make this a little bigger. There we go. Okay, now let's multiply out. Let's give myself plenty of room. Okay, hopefully you can see. Yep. And by the way, if you don't know where these matrices come from, what we did last episode, if you're not familiar with this, then go back to maybe even the inversion of a 2x2 matrix. But if you've watched that video already, then just go back to the previous video where we took some random matrix and then inverted it. Now we're about to prove if that was the correct inversion or not. So let's multiply this out. Remember, dot product, 0 multiplied by that. We're just going to, I don't want this process to be too long, so we're just going to instantly multiply them out. 0 multiplied by negative 1/3, that's just 0. 1 multiplied by 1/3. That's 1/3 plus 1/3. 2 multiplied by 1/3 is 2/3 plus 2/3. Okay, that's our first term. Let's switch. So second term, 0 multiplied by 1/3, that's 0. We're just not, well, we'll write it out. 1 multiplied by negative 4/3, that's still just negative 4/3. It's nice because we have the same denominator all throughout. 2 multiplied by 2/3, that is 4/3. Okay, so let's quickly check it out. So we've already got 1, that's a good sign. And here, this is an additive inverse here. So as a result, we get 0, so that's a good sign. We're already 2 steps to our goal. Now, third pair. 0 multiplied by that, that's just 0 again, plus 1 multiplied by that, that's just 2/3, and 2 multiplied by that, it's negative 2/3, and that becomes 0 again. Let's write this section out. Okay, so now let's switch rows. 1 multiplied by negative 1/3, negative 1/3, 0 multiplied by this, that would just be 0, 0, and 1 multiplied by this. Hold on, so we've done that. 0 multiplied by that, and 1 multiplied by. So how we have not gotten the additive inverse. So we've done this, all that through, and now we're switching rows. Oh, my bad, we're doing it here. Okay, so 1 multiplied by this, sorry. So 1 multiplied by this, 0 multiplied by this, okay. plus 1 over 3. Sorry, I was looking at this row for whatever reason, or column, sorry. So this results in this results in 0, so that's a good sign. So let's switch to the second column. 1 multiplied by that is just 1/3, plus 0 multiplied by this, that is 0, plus 1 multiplied by this, that's 2 over 3. We resulted in 1 there. That's good. 1 multiplied by 1/3, 1/3, 1 multiplied by 2/3, it's 2/3, and 1 multiplied by negative, looks like 1, 0, this is 0, sorry. 0 multiplied by that is 0, so, and then plus 1 multiplied by that, that's negative 1 over 3. So these terms cancel and that becomes 0. Okay, now, is everything fine? Okay, we're not going under the deadline. That's good. So now let's switch to the final row. 2 multiplied by that is negative 2 over 3, plus 1 multiplied by that is 1/3, right? 1/3 plus 1 multiplied by that's 1/3, so that cancels out to 0. Next term, 1 multiplied by 1/3, it's 1/3, plus 0 multiplied by negative 4 over 3, that's 0, plus 1 multiplied by that is 2 over 3, and that's result of 1, which is good. Final term, 2 multiplied by 1/3, that is just 2/3. 1 multiplied by 2/3 is 2/3, so I'm just gonna write that out, 2/3. And 1 multiplied by negative 1/3, that's just negative 1/3. Okay, now let's simplify this. Let's grab another sheet of paper. So this is equivalent to, oh, we can just use the back, sorry. Well, we're gonna have to flip, so that might be a problem. We'll just use another sheet of paper. So simplify, 0 plus 1/3 plus 2/3, that's 1. 1. These terms cancel, they're additive inverses, so 0. These terms are also additive inverses, so that's 0. Let's move it a little to the side here. Negative 1/3, these terms are also additive inverses, so that's 0. This results in 1. 1 over 3 plus 2 over 3 is 1, right? So 1. These terms are also additive inverses, so they're 1, right? 1/3 plus 0 plus negative 1/3, that results in 0. This term, see these terms cancel because this results in 2 over 3 plus negative 2 over 3, that's 0. This is 1. 1/3 plus 2/3 is, oh, that's incorrect. I assume that I have, so what term was that? That was this term, so must have been the second row here, so 1 multiplied by negative 1/4. 1 multiplied by negative. Okay, I've done something incorrectly here, so this is wrong. As you can see, if you want to see, 2 multiplied by 2/3, that's 2/3, right? 2 multiplied by 1/3, that's 2/3. 1 multiplied by negative 2/3, 4/3, that's negative 4/3, plus 2/3, right? Because that's 1 multiplied by that. That cancels out to 0, so that's my bad here. I wonder what I did there. But yeah, the next term is correct. So this is 0, and finally, this term, 4/3 minus 1/3, that is just 1. So here's our identity matrix. So our proof proved this inversion to be correct. So success, I guess. So thank you everyone for watching. Hopefully you enjoyed that video. It was a little it was actually not that tedious, a little less tedious than I would think. Didn't take very long to invert that or to multiply those through 3x3 matrices. I took a shortcut this time, I know, but hopefully it still made sense. Thank you everyone for watching. Have a nice day. See you.